In this class, we will discuss more examples on events. First, recall some concepts. The sample space is the collection of all possible outcomes for an experiment. An event is a collection of outcomes for the experiment, that is, any subspace of the sample space. We say that an event occurs if and only if the outcome of the experiment is a member of the event. In order to correctly find a probability, we first need to correctly identify the sample space and events. We have discussed some examples before. In the following, we will discuss more examples. Assume that the experiment is to randomly select a card from a deck of playing cards. A deck of playing cards contains 52 cards. It has 13 different values from 1 to K and 4 different suits, including spades, hearts, clubs, and diamonds. The sample contains all these 52 playing cards. Now consider some events. Event A means that the card selected is the king of hearts. Clearly, this event includes only one element, which is the king of hearts. Event B means that the card selected is a king. We know that there are 4 kings in a deck of playing cards, 1 king for each suit. Therefore, event B contains 4 members. Event C means that the card selected is a heart. Each suit contains 13 cards, from 1, 2, and up to king. Hence, event C contains 13 elements. Event D means that the card selected is a face card. A face card means a jack, queen, or king. Each face card can belong to any suit. 3 times 4 equals 12. Therefore, event D contains 12 elements. We have mentioned that an event is essentially a set. It is convenient to represent the relationship between events using Venn diagrams. For a typical Venn diagram, the sample space is represented as a rectangle, and the events are disks or other geometric shapes inside rectangle. We may define the operators of events, which can be used to generate new events from existing events. The first one is not E, which is the event containing all elements that are not in event E. The first diagram demonstrates not E. The rectangle is the sample space, or the collection of all possible outcomes. The circle indicates event E. The event not E is therefore the collection of all outcomes falling outside of the circle, which are displayed in green. The second event is A and B, which is the event containing all outcomes in both A and B. In this middle diagram, the green area shows A and B, which is the common area of circle A and circle B. We can see that A and B is a subset of event A. It is also a subset of event B. The third event is A or B, which is the event containing all outcomes in either A or B. The last diagram shows A or B in green. We can see that A or B is larger than A and also larger than B. It includes the outcomes in both of them. Let's see some examples to illustrate these concepts. Let event D be the card selected is a face card. What is the event not D? According to the definition, not D should contain all cards not in D, or contain all non-face card. A non-face card means the value from 1 to 10. Each suit has 10 non-face cards, and in total, event not D contains 40 cards. We have defined events A, B, C, D before. What is the event A and C? By definition, it contains cards in both B and C. We may first check cards in event B and then pick out the cards also belonging to C. The event B has 4 cards, which are 4 kings. Event C means that the card is a heart. Therefore, the only possible card satisfying both conditions for B and C is the king of hearts, which is exactly the event A. We may say that event B and C equals to event A. What is the event C and D? We know that C has 13 cards, which are ace up to king of hearts. The event B requires face cards. Hence, we further pick out face card from these 13 cards, which are Jack, Queen, and King of hearts. Hence, event C and D contains 3 cards. What is B or C? By definition, we should put event C and B and C together and then eliminate any redundancy. The event B has 4 cards and event C has 13 cards. We combine them together. Notice that the king of hearts is in B and also in C. We only need to include it once in the final event. Therefore, we have 16 cards in the event B or C. An important concept is mutually exclusive. 2 or more events are mutually exclusive events if not 2 of them have outcome in common. It essentially means that they are disjoint. In the first diagram of the first row, A and B are mutually exclusive because they are disjoint. In the second diagram, A and B are not mutually exclusive because they share some outcomes in common. In the first diagram of the second row, A, B, and C are mutually exclusive because any pair of events are disjoint. In the second diagram, A, B, C are not mutually exclusive because they share some outcomes in common. In the third diagram, A, B, C are not mutually exclusive. Although A and C are disjoint, B and C are disjoint, we can see that A and B are not disjoint. Hence, we say that A, B, C are not mutually exclusive. To be mutually exclusive, any pair of events should be disjoint. Consider the experiment of randomly selecting 1 card from a deck of 52 cards. We define event C, D, E, F as follows. We will see that events C and D are not mutually exclusive. Event C means cards of hearts and event D means face cards. We know that Jack, Queen, and King of hearts belongs to both C and D. Therefore, C and D are not disjoint. They share some outcomes in common. Therefore, C and D are not mutually exclusive. Event D and event E are mutually exclusive. Event D means face cards, which are Jack, Queen, or King. Event C is ace. Clearly, event D and E have no cards in common. Therefore, D and E are mutually exclusive. Event D, E, F are mutually exclusive. Here, we need to check any pair of events. We have already known that D and E are disjoint. Next, we check D and F. Event F means 8, which is not one of the face cards. Hence, D and F are disjoint. Similarly, E and F are also disjoint. Therefore, events D, E, F are mutually exclusive.